Hello everybody, my name is Elaine Tintoni. I'm the lead online math instructor at ICC, and I'm going to be taking you through this beginning algebra course. We're going to start off in section R.1 talking about fractions, and what we're going to do in this section is learn how to identify prime numbers, because prime numbers will help us simplify fractions. So we're going to learn how to identify prime numbers, how to write numbers in their prime factored form, and then we'll use those two things to help us write fractions in lowest terms. And after we do that, we can do anything else we want with fractions. So I'll show you how to convert between improper fractions and mixed numbers, and I'll also show you how to multiply and divide fractions, and finally how to add and subtract fractions. Here we go. Now I'm going to start off as if you had never heard of a fraction before. So if I say some things that you already know, just hang in there and I will eventually get to where your trouble spot is. But let's just start at the beginning so that we can make sure we're all together understanding the same thing. So fractions are a way to represent parts of a whole. A fraction has a top number that's called a numerator and a bottom number that's called the denominator. And a fraction bar represents division. In other words, the fraction a over b is the same as saying a divided by b. So the fraction bar can always be replaced in your mind with the words divided by. Now, what does a fraction tell us? In a fraction, the numerator gives the number of parts being represented, and the denominator just gives us the total number of equal parts in the whole. So for example, in this figure, it takes 8 parts to make a whole. Notice the parts are all the same size. So 1, 2, 3, 4, 5, 6, 7, 8. It takes 8 to make a whole, but only 3 are shaded. So the shaded region is 3/8 of the whole circle. See, the top number tells you how many parts are being represented, and the denominator tells you how many parts it takes to equal a whole. Now, all fractions can be classified as either proper or improper. A proper fraction has a numerator that is less than the denominator. That means the value of a proper fraction is always going to be less than 1. Here are some examples of proper fractions. 3/4, notice the numerator is less than the denominator, and 3/4 is less than 1. 9/10, again, the numerator is less than the denominator. Or 17/50. All of these are examples of proper fractions. On the other hand, an improper fraction will have a numerator that is greater than or equal to the denominator, and therefore the value of an improper fraction is always greater than or equal to 1. And here are some examples of improper fractions. 11/8. Notice that the top number is more than the bottom number, and so in this case it only takes 8 pieces to make a whole, but we have 11, so we have more than one whole thing. 15/4, and again the numerator is more than the denominator, so if it only takes 4 to make a whole and we have 15, then we have more than 3 whole things, because 4 would go into 15 more than 3 whole times. And 23/2 is also an improper fraction, because clearly the numerator is more than the denominator. But let's look at one more improper fraction. How about 10/10? This is also considered improper because the top number is equal to the bottom number. So in the case of 10/10, it takes 10 parts to make a whole, and we have all 10 parts. So we have a whole unit, and we don't necessarily need a fraction to represent this. This could just as easily be represented by a 1, because remember, 10 divided by 10 equals 1, and remember the fraction bar takes the place of the division symbol. So even when the top number is equal to the bottom number, this is considered improper. Now, when you're working with fractions, it's important to be able to write numbers as products. And remember, a product is the result of a multiplication. Each number in the multiplication is called a factor. So, for example, 12 equals 2 times 6, therefore 2 and 6 are both factors of 12. And you know 12 has a few other factors. But in this case, because the multiplication is written as 2 times 6, we would say 2 and 6 are the factors. Now that we understand the idea of factors, we can start to talk a little bit about prime numbers. In order to make sure that a number is broken down into the smallest possible factors, we need to be able to write numbers as a product of prime factors. So what does prime mean? A prime number is a number that has only itself and 1 as factors. Now, if a number is not prime, it's considered composite, except for the number 1, which is considered neither prime nor composite. All the other natural numbers that are larger than 1 are either considered prime or composite. So, let's see if we can classify a few numbers as either prime or composite. Here we have the number 33. Now, right off the top of my head, I know that 33 is 3 times 11. So since this number has factors besides itself and 1, this number would not be considered prime, therefore it's considered composite. Now think about the number 43. The only number that goes into 43 is 43 itself and 1. In other words, 1 times 43 is the only way to get 43. So we would say that this number is prime. And now think about a large number like 9,832. We don't have to know all the numbers that will go into this number in order to classify it as prime or composite. In this case, just because the number is even, I already know that 9,832 can be written as 2 times something. Now, we don't have to figure out what times 2 makes 9,832, but we certainly could figure that out. In fact, I went ahead and figured out for us that 4,916 times 2 equals 9,832. So we know for sure that this number is composite. Now remember, it wasn't necessary to know the 4,916 in order to tell that 9,832 was composite. It's enough just to know that 2 times something equals 9,832. And if 2 times something equals that number, we know that number is composite. Okay, here are a few more for us to identify as prime or composite. Let's start with 13. We know that the only way to make 13 out of factors is to say 13 times 1, and therefore this number is prime. Now, 27 we know by heart is 9 times 3, and therefore right off the bat, 27 is going to be considered composite. If you know your times table, you know that there are no whole numbers we can multiply together that will give us 59. So 59 is going to be considered prime. And if you look at 1,806, we can tell by the last digit that 2 goes into this number. It's an even number. Therefore, 2 times something makes 1,806. And so that's enough for us to say that this number is composite. Now let's start to move toward writing a number in its prime factored form. We factor a number by writing it as the product of 2 or more numbers. And we typically use a raised dot between the numbers instead of the cross symbol to represent multiplication in algebra, because this cross symbol looks a lot like an X. It's not technically an X, but most of us couldn't tell our times symbol from our X. So we try to stay away from this symbol for multiplication in algebra, and instead we either use parentheses or this dot. Now, if all the numbers in a product are prime, we say that the number is in prime factored form. Let's see if we can write each of these numbers in prime factored form. So first we have 35. Now if you know your times table, you know that 35 is 7 times 5. And see, the dot here represents multiplication, so 7 times 5. Now both of these numbers happen to be prime, and therefore 7 times 5 is the prime factoring for 35. Okay, now let's look at 24. You know, there are a couple of ways to write 24 as a product of two numbers. You can just pick any one that you like and keep breaking down the factors until all the numbers are prime. I'm just going to start with 24 equals 4 times 6. Okay, now notice that neither one of these numbers is prime, so they'll both need to be broken down. 4 can be written as 2 times 2, and 6 can be written as 2 times 3. And now 2 times 2 times 2 times 3 is the prime factoring for 24. Notice that all four of these numbers are prime. And notice that if you multiply them all together, you'll get 24. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. I also want to note here for you that the order you put the factors in does not matter. The factors can be written in any order. The only requirement is that all of the numbers must be prime. For example, if we had written 2 times 3 times 2 times 2, that would still be all the same numbers. Now, MyLabs Plus is always going to show you the factors in order from smallest to largest, but it will accept them in any order. So don't feel like you have to put them in order. Also, if you're in MyLabs Plus and you want to make this dot for your multiplication symbol, you can do that with just an asterisk. So just Shift 8 on your keyboard will make this dot. Okay, now let's look at 150. Now, there are lots of ways to break down 150, but one easy way, since I see this number ends in a 0, is to realize that this is just 15 times 10. So that's where I'm going to start. It's not a rule, but I find that the fastest way to get to the prime factors is to start off with two factors that are relatively close to each other. So, for example, 2 times 75 would have been a choice, but then 75 is still a pretty large number, and we'd have to do a lot of breaking down on that. But 15 and 10 are both pretty small numbers. So 15 can be written as 3 times 5, and 10 can be written as 2 times 5. So now we see that 150 is 3 times 5 times 2 times 5. And those are all prime numbers, so this is the prime factoring for 150. And again, the order that the factors are in does not make any difference. You could rearrange these factors into any order, and they would still be correct, and MyLabs Plus would still accept them as the correct answer. Now here are a few for you to try. I hope that you'll pause the video and try to do these 4 on your own, and we'll do that throughout the course, where I will work a problem first and then I'll give you a chance to work one on your own. And when I do that, it's a good idea for you to pause the video and try it yourself, because there's nothing quite like doing it yourself to make the learning stick with you. Okay, so assuming you've had a chance now to try these on your own, let's go through them together. Our instructions say to write each number in prime factored form. Okay, well, we know that 39 is 3 times 13. And notice that 13 is prime and 3 is prime. So both of these are prime, and therefore this is the prime factoring. And that's all there is to do on that one. On part B, we're asked to find the prime factors for 70. So my first thought is that 70 is 7 times 10. And of course 7 is prime, but 10 is not. So now we'll break down the 10. We need to keep the 7. Okay, so 7, and we'll break down the 10 into 2 times 5. And so now we have 7 times 2 times 5. All of these are prime, so this is the prime factoring. Notice that if I had left the 7 off, all I would have here is 2 times 5, and of course 2 times 5 does not equal 70. You need at the end to have a list of factors that if you multiply them back together, they'll go back to this number that you started with. So 7 times 2 is 14, and 14 times 5 is 70. Now let's look at 72. My first thought is that 72 is 8 times 9. Okay, now neither one of these numbers is prime. 8 can be written as 4 times 2, and 9 can be written as 3 times 3. Okay, now looking at this list of numbers, these are all prime except 4 is not prime, so the 4 needs to be broken down. 4 can be written as 2 times 2, and then we also need to keep these other prime factors that we already found. So 2 times 2 times 2 times 3 times 3. So here's our final list. And let's just multiply these numbers back together mentally and make sure that we get 72. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. And 24 times 3 is 72. So these are the prime factors for 72. And now let's look at 135. You might assume that when a number is large that it's going to be difficult to factor, but it's not always. For example, here I notice that the last digit is a 5, and that tells me that 5 will go into this number. So if I do just a little long division, I can find out that 5 will go into 13 twice, multiply back and subtract, pull down the 5, and then 5 goes into 35 7 times. And so now I see that 135 is equal to 5 times 27. Okay, now 5 is prime, but 27 is not. So let's break down the 27. 27 we know is 9 times 3. And now 5 is prime and 3 is prime, but this 9 is not prime, so we'll break this 9 down into its prime factors. So we'll have 5 times 3 times this other 3, and these 4 prime factors will equal 135. Now I want you to notice that no matter which factors you start out with, the prime factorization always comes out exactly the same. So you can't pick the wrong factors. Any two factors you start with are going to get the job done. For example, remember we factored 24 as 4 times 6, and then we broke down the 4 and we broke down the 6, and so these were our prime factors. Well, if we had started with 24 equals 3 times 8, then we could have said 3 is prime and 8 is 4 times 2. And then we could have broken down this 4 into 2 times 2. So here's our 3, and 2 times 2 times 2 is 8. And so notice that even though we took two different paths to get there, both paths ended with the same factorization. 2 times 2 times 2 times 3, 2 times 2 times 2 times 3. And again, the order that the factors are in does not matter. Now we're going to move into talking about how to write fractions in lowest terms. In other words, how to simplify a fraction. So you need to realize that it's possible for two different fractions to represent the same quantity. Think about money. So consider 50 pennies, and you know that would be 50 cents. And 50 cents can also be represented by 5 dimes, and 50 cents can also be represented by 2 quarters. So these are three different ways of having 50 cents. Now remember, the denominator of a fraction tells you how many pieces it takes to make a whole. So if you have 50 pennies, you have 50 items, but it takes 100 to make a whole. So the fraction would be 50 over 100. And if you have 5 dimes, then you have 5 pieces, but it only takes 10 dimes to make a whole. So the fraction here would be 5/10. And if you think about quarters, you know it takes 4 quarters to make a whole. So you have 2, but it takes 4 to make a whole. And since each of these amounts represents half a dollar, we know that each of these fractions is equivalent to 1/2. Now remember, we talk about writing fractions in lowest terms, but we can also say we're reducing the fraction or simplifying the fraction. Both of these words mean the same thing as writing in lowest terms. Now, to simplify a fraction, we'll use what's called the properties of 1. So think about the number 1. Any non-zero number divided by itself is equal to 1. For example, 3 divided by 3 is 1. So we see that if we have a number in the top and the same number in the denominator, they divide out and they form a 1. And also notice that any number multiplied by 1 remains the same. So 2/5 times 1 still equals 2/5. So this is where we get the idea of canceling out. And canceling is not the right term, but we do say it. So if a number is a factor of both the top and the bottom, it will cancel out and form a 1, and therefore it has no effect on the value. So any number times that 1 that we got from canceling out is still the same number. And now we consider a fraction to be in lowest terms, or we consider a fraction to be simplified when the numerator and the denominator have no factors in common except for 1. So here's how to write a fraction in lowest terms. So first, write the numerator and the denominator in prime factored form. Now, you don't always have to go all the way to prime factors. You may be able to spot larger numbers that appear in both the numerator and the denominator, and in that case it won't be necessary to factor those all the way to prime. Step 2, replace each pair of factors common to the numerator and the denominator with 1. In other words, let those like factors that are in the top and the bottom cancel out. Remember, it has to be a top and a bottom factor. You can't have 2 3's in the top and have them cancel out, or 2 3's in the bottom. It has to be a top and a bottom. And then multiply the remaining factors in the numerator back together and multiply the remaining factors in the denominator back together. Let's practice a little bit. Okay, so let's start with 10/15, or in other words 10 divided by 15. So an easy way to see what's happening when you reduce a fraction is to factor the numbers out. So 10 can be written as 2 times 5, and in the denominator 15 can be written as 3 times 5. Now notice here that 5 divided by 5 would make a 1. So I'll just cross through those. They are not having any effect on the value of the fraction. And so what's left now is 2/3. So that's how you simplify a fraction. Let's look at 15/45, so 15/45. Now, if you really know your times tables well, you might notice that 15 goes into 45, but let's say you didn't notice that at first. So we could write 15 as 3 times 5, and the idea is to get a common factor in the top and in the bottom. So now I'm going to write 45 as 9 times 5. And again, we see a 5 in the top and the bottom, so we'll cross out the 5's, and that leaves us with 3/9. Now, notice that we're not finished yet, because a fraction is only considered completely simplified if the top and the bottom share no common factors, but we know that 9 is 3 times 3. So now let's write 3/9 as 3 in the top, but 3 times 3 in the bottom. And now we can cancel out a pair of 3's. Now, whenever you cancel out the only number that's in the top, you really haven't lost the top number, because any number can be considered as times 1. So notice that when I crossed out the last number in the top, I put a times 1 there. So now you can see that 3/9 simplifies to 1/3. And now let's look at 150/200. Now I notice that both of these numbers end in zeros, so both of these numbers can be written with factors of 10. So I'm going to say that 150 is 15 times 10, and 200 is 20 times 10. And now notice I can cross out the 10's right off the bat. But also notice that 15 and 20 share a common factor. They both can be divided by 5. So let's write 15 now as 3 times 5 and 20 as 4 times 5. And now I'll cross out the 5's because that is what is common to both the top and the bottom. And that leaves us with 3/4. And there we know we're finished because 3 and 4 do not share any common factors. Now here are a few fractions for you to try simplifying on your own. So again, pause the video and try these on your own and then check them with me. And now I'm going to go through them with you. So if we try to simplify 8/14, we notice that both of these numbers can be divided by 2. I'm going to write 8 as 4 times 2, and I'm going to write 14 as 7 times 2, and now I'm going to cross out the 2's, and what's left is 4/7. So 8/14 reduces to 4/7. And here we have 10/70. So I know that 70 is 7 times 10. So I don't see any use in breaking down the 10 into 2 times 5, because I know that if I break down the 70, I can have a 10 in the bottom. So I'm just going to say 10 over 7 times 10. And now I'm going to cross out the 10's, but I don't want to leave the top empty, so I'm going to remember that 10 can also be written as 10 times 1. And so now I see that 10/70 reduces to 1/7. And let's look at 36/60. Right away I notice that both of these numbers contain a factor of 6. So I'm going to write 36 as 6 times 6, and I'm going to write 60 as 6 times 10. That way I can cross out the 6's, and that's a good start, but notice that 6 and 10 also share a common factor. So now I'm going to break the 6 down into 2 times 3, and I'm going to break the 10 down into 2 times 5. And notice that we have a 2 in the top and a 2 in the bottom, so we'll cancel those out, and that leaves 3/5. So 36/60 reduces to 3/5. Now let's move on and talk about how to convert between improper fractions and mixed numbers. So first, what is a mixed number? A mixed number is a single number that represents the sum of a natural number and a proper fraction. So you'll have a whole number here that's something 1 or more, and you'll have a fraction here that must always be a proper fraction. Now first, let's talk about how to convert an improper fraction into this mixed number form. So to convert an improper fraction to a mixed number, you just have to remember that the fraction bar represents division. So you're going to perform the long division and use the remainder as the numerator of your new proper fraction. And the denominator will always stay the same. So here's an example for you. We want to write 59/8 as a mixed number. So first we'll have to remember that this fraction bar represents division. So we'll say 59 divided by 8. It's always top number on the inside, bottom number on the outside. And now ask yourself, how many times does 8 go into 59? Well, we know that 8 times 7 is 56. So I'll say that 8 goes into 59 7 times. Multiply back and subtract, and we see that the remainder there is 3. Now notice that 8 went into 59 7 whole times. So 7 is the whole number. And this 3 is the leftover pieces. So this 3 becomes the numerator of our fraction. And how many pieces does it take to make a whole? Well, it still takes 8 pieces to make a whole, so this is still the denominator. Okay, so now 59/8 has been converted to 7 whole things and 3/8. Now here's one for you to try. So again, pause the video and try it yourself. And now I'm going to go through it with you. So we know that 92/5 can also be thought of as 92 divided by 5. So we will set up our division, top number inside, bottom number outside, and now 5 goes into 9 one time, multiply back and subtract, and pull down the 2, and now 5 goes into 42 8 times, and there's 2 left over. So we see that 5 goes into 92 18 whole times, so 18 is the whole number, and the number of pieces left over is 2, and it still takes 5 pieces to make a whole, so 5 is still the denominator. And so 92/5 converts to 18 and 2/5. Now let's go the other direction. To convert a mixed number to an improper fraction, first we will multiply the denominator by the whole number, and then we'll add that to the numerator, and that becomes the numerator of the new improper fraction. Again, the denominator stays the same. Here's an example for us. This one says write 6 4/7 as an improper fraction. Well, you can use the steps I just showed you, and we are going to do that, but I thought I'd also just illustrate this for you a little bit. So notice that 6 4/7 would mean that we have 6 whole things, you could think about pizzas maybe, and 4/7 of an additional thing. Okay, to find out how many sevenths there are, we could cut each of these whole pizzas into 7 pieces. So let's just do that, and then we could count the sevenths. We'd have 7 here, 7 here, 7 here. So 1, 2, 3, 4, 5, 6 whole pizzas that each have 7 pieces. So that would be 42 plus these 4 equals 46 sevenths, because it takes 7 pieces to make a whole pizza. But you don't want to have to be drawing pizzas and counting pieces all the time. So let's try to use our shortcut. If we take our mixed number, all we have to do is multiply the denominator times the whole number. 7 times 6 is 42, and then add that to the numerator. 42 plus 4 is 46, and remember the denominator stays the same. So this is all we have to do to convert from mixed form to improper form. Although if it helps you to kind of visualize this process, then I think that's a great idea too. I just don't want you spending a ton of time drawing circles and circles and circles. Okay, now here's one for you to practice. Write 11 2/3 as an improper fraction. Try it on your own, and now let's do it together. So we're going to take 11 2/3, we're going to multiply denominator times whole number, that'll give us 33, and then we're going to add that to the numerator. 33 plus 2 is 35. So now we've got 35 thirds, because remember, denominator stays the same. Now we're ready to talk about how to multiply and divide fractions. Let's start with multiplication. Fraction multiplication is super simple. Don't make it hard. You know, when you were back in elementary school and you first learned how to add fractions, it wasn't long before your teacher introduced common denominators. And I think when people learn common denominators so young, it all seems so overwhelming. You're thinking about things you can't really visualize or touch, and it gets really hard to comprehend. But you need to just take a step back. Fraction multiplication is not difficult. It does not require common denominators. All you have to know is that when you multiply fractions together, you do top number times top number, see? And bottom number times bottom number, see, like this. So if we have A over C times B over D, then when we multiply them together, the top is just A times B, and the bottom is just C times D. Now here's the catch. If either numerator contains a factor that is also in either denominator, we want to cross those out before multiplying. It is going to be much easier for you to do your simplifying on the front end than it is to do your simplifying after you've multiplied the numbers together. Because when you multiply numbers together, they get larger. And then if you have to simplify, you're basically just undoing the multiplication that you just did. So why would you multiply numbers together and then have to turn around and unmultiply them? See, it doesn't make sense. So we want to do our crossing out before we do our multiplying. And here's a piece of good news. It's okay for the answer to be improper. So if we multiply two fractions together and we get an improper answer, that's fine. That is not a problem. The only time we will have to worry about converting an improper answer into a mixed number form is if we started out with a mixed number problem. But for two fractions like this, if we multiply them together and we get an improper answer, we just leave the answer in improper form. However, we are responsible for writing the fraction in lowest terms. In other words, we are responsible for simplifying. So here we go. Let's find each product and then write it in lowest terms if we need to. We'll start with 3/8 times 4/9. Now we could multiply 3 times 4 is 12 and 8 times 9 is 72. We could have 12 over 72, but we would then have to simplify that fraction. So all I'm saying is right now, while we have small numbers to work with, let's separate these into their prime factors. I see that I have a 4 in the top here, and I know that 8 can be written as 4 times 2. So I'm going to write this fraction as 3 over 4 times 2. See, that's 8, but I've written it so that I can see the 4. Now that's going to be times 4 over 9. But since I see that there is a 3 in the top here, I know I want to cancel out that 3 if possible, so I'm going to write 9 as 3 times 3. Okay, now I have a 3 in the top and a 3 in the denominator, so let's cross those out. And I also have a 4 in the top and a 4 in the denominator, so let's cross those out. And now it appears that there are no numbers left in the top, but we know that whenever all the top numbers are crossed out, there's always a 1 there, because any number can be written as times 1. And so now we have 1 over 2 times 3, and 2 times 3 is 6. And so if you will learn to multiply fractions by doing your crossing out first, then your answer will always come out simplified. Now let me show you a way of writing this that may be a little bit faster for you. I think you're actually going to want to graduate to this way of writing it eventually. So we could start with 3/8 times 4/9. And instead of writing out the factors, you can do this mentally. You can say, okay, I see a 3 in the top and a 9 in the bottom, and both of these are 3 times something. So if I cross out the 3's, what's left? Well, this is 3 times 1. So if I divide out the 3, all that's left is a 1. And this is 3 times 3, so if I cross out one of those 3's, there's another 3 left. In other words, just divide both of these numbers by whatever they have in common. 3 divided by 3 is 1, 9 divided by 3 is 3. And do the same thing here. Both of these numbers are 4 times something. So I could say 4 divided by 4 leaves 1, and 8 divided by 4 leaves 2. And now I can just multiply top times top. 1 times 1 is 1. And in the denominator, 2 times 3 is 6. We're doing the same multiplication, but it's just two different ways of writing it. This way is maybe easier when you're starting out, but I think just for purposes of speed, you're going to want to go here as soon as possible. Now let's try part B, and we'll try it using the second way that I showed you. Okay, so I'm going to recopy my problem, and now I want to look and see if I see any factors that are repeated in the top and the bottom. Here I have a 4, and here I have an 8, which is 4 times 2. So I see that both of these numbers can be divided by 4. I also see here a 5 and a 7. Now the 5 in the top is not repeated in the denominator, and the 7 in the denominator is not repeated in the top. So all we're going to be able to do is cross out the 4's. Okay, 4 divided by 4 is 1. And again, 8 divided by 4 is 2. And now let's multiply top times top, bottom times bottom. Top times top is 1 times 5, which is 5. Bottom times bottom is 7 times 2, which is 14. And there is our simplified answer. Now let's talk about how to multiply mixed numbers together. Before you multiply mixed numbers together, always convert them to improper fractions. We never multiply with mixed numbers because they do not follow the same rules as other numbers. So in order to get around having to learn a new set of rules for mixed numbers, it's easiest for us to just convert those to improper fractions. Okay? And on mixed number problems, If you come out with an answer that is improper, you should convert it back to mixed number form. You can think of it like you always want to leave the answer in the same form that the problem was in. So if the problem is mixed numbers, then you want to leave the answer as a mixed number if it's more than one. If the problem was regular fractions, you can leave the answer as a regular fraction. So here are a couple of examples. Here we have 2 1/3 times 5 1/4. So I'm not going to try to work this in mixed number form. The first thing I'm going to do is convert this mixed number to an improper fraction. 3 times 2 is 6, and 6 plus 1 is 7. So this becomes 7/3. And for the second fraction, 4 times 5 is 20, and 20 plus 1 is 21. So this becomes 21/4. Okay, now I want to see if I can find any factors that are repeated in both the top and the bottom. And I see here that I have a 21, and 21 is 7 times 3. So I can use the 3 that I'll get here to cross out the 3 in the denominator. But that's all we're going to be able to do because 7 and 4 do not share any factors. So let's go ahead and say we're going to divide both of these numbers by 3. 21 divided by 3 gives us 7, and 3 divided by 3 gives us 1. And now multiplying top times top, 7 times 7 is 49, and in the denominator 1 times 4 is 4. And now remember that this was a mixed number problem, and this is an improper fraction, so it will need to be converted to mixed number form. So we'll do the division. We'll say 4 goes into 4 one time, subtract and pull down the 9, and 4 goes into 9 twice, and then multiply back, and we have a remainder of 1. So 49/4 converts to 12 1/4. Now here's one that you should maybe try on your own and make sure that you are picking this up. And now I'm going to go through it with you. So first, because these are mixed numbers, let's convert to improper fractions. 3 times 2 is 6, 6 plus 2 is 8, so this is 8/3. 5 times 1 is 5, 5 plus 3 is 8, so this is 8/5. Okay, now see if you can find any common factors between the top and the bottom, and we cannot find any common factors, so we'll just multiply. 8 times 8 is 64, and in the denominator 3 times 5 is 15. And now because this was a mixed number problem, we'll have to convert this to mixed number form. 15 goes into 64 4 times, because you know that 15 times 4 is 60. Okay, multiply back and subtract, and we see that 64/15 converts to 4, and 4/15. And now let's talk about fraction division. Okay, so if you have two fractions that you're dividing, there is a very simple rule. To divide by a fraction means to multiply by the reciprocal. And the reciprocal just means to turn the fraction upside down. And then you can treat it like a multiplication problem. We'd multiply top times top to get AD here, and bottom times bottom to get BC. So to divide two fractions, convert the division problem to multiplication form. See, this way we don't have to learn a new set of rules about how to divide. We just convert to multiplication form and use our multiplication procedure. And as I said before, to divide by a fraction means to multiply by its reciprocal, and the reciprocal, by the way, is sometimes called the multiplicative inverse. That's just the long name for it, and you may not see it here, but I want you to know it in case you see it in another course for some reason. So reciprocal sometimes is called multiplicative inverse, and the reciprocal of a fraction is just the same fraction but turned over. So the bottom becomes the top and the top becomes the bottom. Now always remember to simplify your answer if possible, or in other words, always write the answer in lowest terms. But keep in mind that simplifying just means crossing out the common factors from the top and the bottom, and the word simplify does not mean that you necessarily have to change an improper answer into mixed number form. We only convert into mixed number form if we had a mixed number problem to begin with. So let's practice together a little bit of fraction division. Okay, first we want to convert to multiplication form. So 3/4 times 5/8. To divide by a fraction is to multiply by its reciprocal. Now that we've got it in multiplication form, we can cross out any like factors that we see in the top and the bottom, but I don't see any. See, now that we've got it switched into multiplication form, you can see that the 8 and the 4 are both in the denominator, so they're not going to cancel out at all. So we'll just have to say 3 times 5 is 15, and in the denominator 4 times 8 is 32. This cannot be reduced, and so we'll just leave it like that. Our final answer here is 15/32. Okay, let's try part B. 3/4 divided by 5/8. So first we convert to multiplication form, and this will become 3/4 times 8/5. And now that we're in multiplication form, we can cross out any like factors. So I see that 8 is 4 times 2. In other words, these two numbers can both be divided by 4. 8 divided by 4 is going to leave 2, and 4 divided by 4 is going to leave 1. So now multiplying top times top, 3 times 2 is 6, and in the denominator 1 times 5 is 5. And this is an improper fraction, but because this was not a mixed number problem, I'm just fine leaving this answer in improper form. Okay, now let's try 5/8 divided by 10. So I think the key here is to recognize that 10 is a fraction. It's just in disguise because you can't see its denominator, but any whole number always has a denominator of 1. So 5/8 divided by 10 becomes 5/8 times 1/10. And now that it's in multiplication form, you can see that we're going to be able to cross out a 5 here. 5 divided by 5 is 1, and 10 divided by 5 is 2. Okay, now multiply top times top and you'll get 1, and multiply bottom times bottom and you'll get 16. So our final answer here is 1/16. And let's try this mixed number example. 1 2/3 divided by 4 1/2. I think the key here is just to not get ahead of yourself. We know that we're going to need improper fractions in order to do this, and we also know we have to change from division form to multiplication form. You only need to do one thing at a time. So what I always do first is convert to improper fraction form, because in fact you can't do a reciprocal while you're in mixed number form. So first let's get into improper fractions. 1 2/3 will be 5/3, and 4 1/2 will become 9/2. So now we have 5/3 divided by 9/2, and I haven't yet converted to multiplication form, so now I'll do that, and this problem will become 5/3 times 2/9. And now ask yourself if there's anything you can cross out top and bottom, and there is not, so we'll just have to do top times top is 10, and bottom times bottom is 27. This fraction cannot be simplified, and it's also not even an improper fraction, so it also can't be converted to mixed number form. But if it were improper, we would be required to convert it back to mixed number form because this was a mixed number problem. Now here are two examples that you can try on your own just to make sure that everything is sticking the way it should. And if you've had a chance to pause the video and try these on your own, now I'm going to go through them with you. So this is 4/3 divided by 16/7. So dividing by a fraction is the same as multiplying by its reciprocal. So I'll just write it in multiplication form. And now I can notice that I have a 4 and a 16, so I'm going to be able to divide both of these by 4. 4 divided by 4 is 1, and 16 divided by 4 is 4. And now 1 times 7 is 7, and in the denominator 3 times 4 is 12. and that one cannot be simplified, so that one's finished. And now let's try part B. We'll convert our mixed numbers to improper fractions. 3 1/4 becomes 13/4, divided by 1 2/5 becomes 7/5. Now convert from division to multiplication, so this is 13/4 times 5/7. See if you can do any reducing. In this case we cannot. So 13 times 5 is 65, and in the denominator 4 times 7 is 28. Now this is an improper fraction, and since this was a mixed number problem, we need to convert this answer back into mixed number form. So let's just come up here and do the division. 28 will go into 65 only twice, and multiply back. 2 times 28 is 56, and then subtract and you'll get 9. So 65/28 converts to 2 and 9/28. And that's it. See, not so bad. So multiplying and dividing are very similar operations. All you have to do to get from division to multiplication is change the division symbol to a times symbol and then flip the second fraction, and that's all. From there out, they're the same process.